Good morning and good evening, friends. Welcome to goonlinetrainings.com. Yesterday, we are done with the demo number one. Today is the part 2 demo. Today is the final demo class on Azure Data Engineering. So, as part of Azure Data Engineering, you have to know what is a cloud or cloud fundamentals. That is what I have explained briefly in yesterday's class. And after that, I was talking about big data. So yesterday I was talking about introduction to big data and how IT industry is going to be storing the data. What are the things it has? So those things we have discussed in yesterday's class. And what is the three V's of big data I was talking about? And what was ADF, Azure Data Factory? What was ADB, Azure Data Bricks? Okay, what is ADF and what is ADB? I have given clear-cut introduction about these two in yesterday's class itself. People who missed it, they need to watch that video without fail. And also, I spoken about what is Hadoop and what is Apache Spark and what is Databricks also I have spoken about yesterday. So today let us understand what is cluster. Okay, why everybody is going to talk about a cluster, why we need to use a cluster, all these things I'm going to be discussing today. So we're going to understand. Let me open my notes. Okay. Yesterday, I was talking about IT industry is going to be doing only two things. So, what are they? IT industry always going to store your data. That is one thing we need to understand. And IT industry is going to be processing your data or computing your data, right? If you wanted to store your data, depends upon the size, IT industry is going to be storing the data in different platforms. When you have a small amount of data, IT industry is going to be storing the data into the files, CSV file, text file, Excel file, PDF file, blah blah blah. When the data is there in GBs, it is, if the data is in megabyte or kilobyte of size, the data can be stored in the files. If it is data is there in GBs, IT industry is going to be using a technology called SQL. That is what I told you yesterday. And if the data size is in terabytes, right? IT industry invented one more technology called data warehouse, right? If the data is in a petabyte, zettabyte, that is unlimited data, petabyte of data, zettabyte of data, yottabyte of data. So when you have a large amount of data, IT industry is going to be storing the data into a system called Hadoop or technology called Hadoop. Hadoop is gone today. We are going to be using Apache Spark. Okay, Apache Spark. So we are talking about year 2025, right? So IT industry has only four things to store the data, only four technologies, either file or your data may be in SQL called as RDBMS, or your data may be there in the data warehousing, or if you have more amount of data, bigger amount of data, either you're going to be storing the data into the Hadoop or Apache Spark. Hadoop is having some kind of an issues, so Hadoop is introduced in the year 2005, and Hadoop is gone today. People are not using Hadoop because Hadoop is slow. Hadoop is introduced in the year of 2005. Apache Spark is introduced in year 2000, I think 9. Clear? So Apache Spark is the big data technology. This data is called as a small data. So whatever we are seeing it here, this data is called as a small data. Now Google has given a beautiful name to the petabyte of data, zettabyte of data. This is called as a big data, right? So we have a small data and we have a big data. Big data means unlimited data. Unlimited data means petabyte, zettabyte of data. So this is where the companies are going to be storing the data. When you store the data, what is that we're going to be doing? On this data, two people are going to be taking your data. Okay. So either you take this data from here, maybe take the data from here, or you take the data from here, or you take the data from here. So one is called AI, artificial intelligence is going to be working with your data, or a BI team is going to be working with your data. BI is also called as a data analytics team. AI is called as machine learning team. Clear? So two people are going to be working with your data. Data may be in files, data may be in SQL or RDBMS, data may be in data warehousing, or data may be in Hadoop, or Hadoop is gone today. Apache Spark, where your data is available, right? Unlimited data, very big amount of data. What is the purpose of AI, artificial intelligence? It is going to be, predicting the future. Predictions are going to be done. Okay, so AI, or that is prediction. It's going to be predicting the future. Predictions are going to be done with the help of AI. BI, business intelligence or data analytics, is going to be understanding past. Clear? Both of them are, are doing two different activities, but both of them need your data. Clear? But who's going to be collecting data, cleansing the data, storing the data? The guy is called a data engineer. The guy is called data engineer. If you wanted to become a data engineer today, you have to know SQL, data warehousing, and more towards Apache Spark or Hadoop. Clear? Because as a data engineer, large amount of data we are going to be dealing with. So the backbone for the data engineering is you should know SQL very well. That is step number one. Without SQL, you will not be able to get any knowledge because you're a data engineer. Step number two, you should know data warehousing knowledge. What is a data warehouse? What is a data mart? So, and you are going to be learning what is Apache Spark. Big data also, you should be able to know Apache Spark. If you wanted to write the coding in Apache Spark, you should know Python language or Scala. By default, you will be able to get it. So SQL, it will be minimum. We have 60 hours of syllabus in SQL. In depth of SQL, you need to know. And data warehousing, 10 hours of syllabus we have. Right? In depth of data warehousing. In that, I'm going to be talking about what is a dimension, what is a fact, what is a star schema, what is a snowflake schema, what is a normalization, what is a denormalization, right? What is different measures, what are the different dimensions, junk dimension, role playing dimension, conform dimension, slowly changing dimension, additive measure, semi additive measure. So all these things are going to be asked in the interview. So 10 hours of detailed sessions, recording videos, I'm going to be giving it to you. You must know what is a data warehousing, what is a data mart in depth. Clear? Not basic level. So that one you need to know. And SQL, people will ask you what is a primary key, what is a foreign key, what is a data modeling, how do you retrieve the data, what is a joins, what are the subqueries, correlation subqueries, primary keys, foreign keys, relationships, unique keys. And you should know how to write store procedures, how to use different aggregate functions, string functions, date and time functions, mathematical functions. All these things you need to know as part of SQL, right? So without SQL, you don't jump into IT industry. And if you know basic understanding of SQL, that is not sufficient. Don't tell me, sir, my friend taught, teach me SQL, or I have Udemy videos, I will learn from them, or I have joined one institution in Amirpet, so they'll be teaching, videos. So all the basics we do not need. We need advanced level because we are expecting minimum 3 years experience when you keep, we are expecting 15-20 lakh salary package. What is the salary package we're expecting? Even though you're a non-IT guy, if you wanted to get into data engineering position, minimum 3 to 4 years of experience when you put it, we are expecting minimum 15-20 lakhs of salary packages. Your interview is going to be starting started will be SQL only. They'll be grilling like anything. If you don't know anything about SQL, then if you're learning SQL, only 4 hours of SQL, I know 10 hours of SQL, I know basics I have done in my college, that SQL is not sufficient. Clear? So the backbone for the data engineering role will be SQL. 60 years I'm going to be giving it to you. Daily one video you just watch. 20 videos per month. 20, 20, 20. 3 months you can complete very easily 60 hours of videos. So out of that, you, even though you remember 50% of syllabus, that is more than sufficient to crack. I'm going to be giving you very complex case studies to practice. You must take the SQL videos and practice data warehousing also. I'm going to be giving you very basic to advanced level of data warehousing and designing of data warehousing architecture. You don't get all of them in the YouTube. Even though you buy thousands of books, you go to bigger institutions, you don't get in-depth of syllabus of SQL and data warehousing. Yeah, am I clear? Fourth one, I'm going to be talking about now Apache Spark. Apache Spark is completely easy, but more coding will be there. If you know SQL very well, understanding Apache Spark will be easy, right? Because we are going to be dealing with the more amount of SQL concepts only in Apache Spark, but we are going to be implementing those concepts using Python, or we're going to be implementing those concepts using SQL, right? Apache Spark, end of the day, it is going to be dealing with the data. Data means more of SQL concepts are going to be getting repeated in your Apache Spark as well. So Apache Spark, if you wanted to learn, SQL is the again backbone. So you need to use a coding called Python, right? So when you wanted to get the data from files or SQL data warehousing, somebody has to store the data. Who's going to be doing that? Data engineering team is going to be doing. Data engineer, you need to know, as a data engineer, you need to know SQL, data warehousing, and Apache Spark very well, plus Python. So that is what. So Synopsys is going to be your ready-made data warehouse for the data analytics purpose, especially for the BI people, ready-made data warehousing analytics work they're going to be implementing. That is what is called Azure Synapses. That you're going to be learning later. So AI team is going to be predicting the data. BI team is going to be getting your data maybe from here, maybe from here, maybe from here, maybe from here, and they'll be doing a lot of past understanding. Understanding the past is called data analytics, and predicting the future is called AI or ML. Now, Chart GPT, we are talking about Chart GPT, right? Chart GPT is what kind of an application? It is a AI application, but it is not a pure AI application. It is a Gen AI application, generative AI application. So, normal application, normal AI is going to be predicting, right? Generative AI application is not going to predict anything. Instead of that, it is going to be generating what? Generating a text, or generating audio, or generating a video. So it is called as a Gen AI. Gen AI is going to be getting the data where? Gen AI is going to be getting the data from the Hadoop or Apache Spark. What is the size of the data we're expecting here? We are going to be expecting the data, not very small amount of data, very, very big amount of data. It will be 1,000 Himalaya size. That is the data now we are going to get from this Hadoop or Apache Spark. Am I clear? So petabyte, zettabyte, yottabyte of data Chat GPT is going to be getting, but this Himalayas of data, when you burn the data into DVDs and when you stack them, okay, you will have thousands of Himalaya size of data we are now using as part of your co-pilot Chat GPT, and AI application is going to be called as ML application, machine learning application. Machine learning application uh, can deal with a small amount of data. Today, machine learning is gone. We are going to be using a deep learning. Clear? In the deep learning, we are going to be using large language models. Clear? Large language models we are using. Machine learning can deal with the small amount of data. We are talking about Chat GPT is going to use large amount of data. Chat GPT application is built not on the machine learning, it is built based on the deep learning. Machine learning can work with a small amount of data. Deep learning can work with the large amount of data, petabyte, zettabyte of data we are talking about today. Your AI application today, Chat GPT, is not a ML application. It is a deep learning application. Deep learning is going to work with the large data sets. So where are the large data sets are going to be stored in the Apache Spark? But how Apache Spark is going to be storing your data, even though you have unlimited data, billions, trillions data, we are able to bring it today, how it is going to be storing the data. So that is what we are going to be learning. So your Apache Spark system or Hadoop system is going to be using a cluster. Okay. So how it is able to store a large amount of data, because you don't have any other technology. If you have small data, file, medium data, SQL, large data, you can use data warehousing, then Excel data, double Excel data, triple Excel data, extra large data. That's it. My unlimited data can be stored in only Apache Spark, earlier Hadoop, right? Apache Spark is introduced in year 2009, right? So that was a story I was talking about how it is able to store. So that is what we are going to be understanding today. As I discussed, Hadoop is introduced even in 2003 and 5, I think. Probably it is released in 2005. But the concept, big data concept, is introduced in year 2003. And the Apache Software Foundation, this is a charitable organization. They have released Hadoop software in 2005, actually. It is free, end of the day, we are going to be storing the data, processing the data. For the storing purpose, we are using HDFS. Everything I have discussed in the previous class. And all the data can be stored in the disk. Because of that, Hadoop is become slow. Right. And Hadoop is going to be processing the data with the help of a map reduce. It is a Java program. Java program is complex. Because of these two reasons, it is a large amount of data, one, and it is storing the data into the disk. Because of too slow, and writing a program will be too complex. Writing a program will be too complex. Okay, so that is what you got to understand. So many IT industry has given a negative feedback. Immediately, Apache Software Foundation is released one more software called Apache Spark. Right? Apache Spark is a new framework. It is being released to store the big amount of data. So two things we are going to be doing with the data. One is called storing the data. Second one is called processing the data. Only two operations, right? So storing the data, then we are going to be processing the data. So in Hadoop also, we are going to be storing the data, processing the data. But if you wanted to store, you need to have some kind of an architecture. Earlier, Hadoop was storing into disk, but now Apache Spark is going to be storing your data into the RAM, right? Because of that, it was very, very, fast. That is one thing you have to know. End of the day, big data is gone, and Apache Spark is released actually in 2009, not 6. It is now Apache Spark is going to be storing data into the RAM, and it is going to be processing the data with the help of a different language, which is very, very fast. Why? It is not storing into the hard disk. Disk means hard disk. Anything which you store in the disk will be slow, right? It is going to be storing everything in the RAM. Because of that, it is going to be, many people are telling, 30 to 100 times the Apache Spark system is faster, and Apache Spark is completely free software. Even Apache Hadoop is also free software. Am I clear? So now process the data. We're going to be using a language. Now, earlier we were using a map reduce algorithm, and a map reduce algorithm can be created using a Java. Java is a very, very complex language. Keeping it in mind, Apache Foundation Company has given you one more language with Apache Spark. The language is called as a Scala. Scala is very, very easy language. Now everybody using Python today, so every community using Python today, and Apache Spark team is also told you can also use Python language. Even SQL language you can use, or people who know Java, they can also use Java. But Java is complex. Either you can use Scala, Python, SQL. These are easy languages, and you can also go in for Java. Java you can use, or any other language. You can use R language if you know it. So you have the data that is there in the RAM to process the data. Processing means what kind of operations we're going to be doing? Processing means we're going to be doing two operations. One is data cleaning work we're going to be doing, and a data aggregation work we're going to be doing it. Clear? So two operations we're going to be doing with the data. So one is called data cleansing. It is what is called as a transformations. For example, I have a male is there, I have female is there. Wherever a female is there, I would like to make it to one. Wherever there is a male, I need to make it to zero. So I want to transform, or I would like to change the data. Wherever there is a F, I would like to make it to one. M is there zero. Or wherever there is F, I wanted to write full spelling. Okay. Wherever there is a M, I need to write full spelling. Or wherever a full spelling is there, take the first letter. Wherever the full spelling is there, I want to get the first letter. Whatever you wanted to write, whatever be the transformation. Transformation means a change. I have a billions and trillions of data. What normally we do? We are going to be getting the data into the standard format. For example, you are giving me some data. I am also, having some data. Your data has male and female. My data has ones and zeros. Okay. So gender column is there. In the gender column, I have F and M sometimes, male and female sometimes, ones and zero, male and female, and full spelling I have. So I cannot have all the data. One file will be having this data. One more file is having gender data like that. One more file is going to be having full spelling, right? I wanted to combine the data of the three files. Clear? Employee ID, employee name, employee gender is there. But gender column has having different formats. Sometimes zeros and ones in some file. In some file, I'm having male complete spelling, female complete spelling. In some other file, I'm having yes or no. Are you male? Yes, no. In some other file, I'm going to be having only F and M. So I cannot combine the data as it is. What I'm going to be doing, I'm going to be getting the data from the file number one, file number two, file number three, file number four. All the data I want to dump and create a bigger file, and I create them in the standard format. Clear? We are not talking about small amount of data here. We are going to be talking about large amount of data, billions and trillions of data. That is what is all big data all about, right? So now, how you're going to be processing? Because for example, I wanted to sum two numbers. I wanted to sum five numbers. I wanted to sum thousand numbers. I wanted to sum billions and trillions of numbers. Now, see the difficulty when the size is going to be increasing, how the things are going to be happening. Whether it is data cleansing work. Okay. So I need to convert the data into the proper format. We are going to be cleansing the data or transforming the data. One activity, either Apache Spark or maybe Hadoop is going to be storing your data. That is one part. Second one, you have to start cleaning, because end of the day, if you don't clean the data properly, you will have very big, wrong data analytics, wrong predictions are going to come. Whatever goes in is wrong, comes out will be wrong. So what is the biggest headache of your, data engineering will be cleaning the data. Data will be messy. Biggest issue with the data way is completely bad data, wrong data, right? Duplicated data, misspelled data, blank data, not proper patterns. Clear? These are the biggest issues that you're going to be having in your data engineering team is going to be having this kind of a challenges, right? So you will have tons and tons of data, but the cleaning is very, very difficult. After cleaning the data, storing, after the storing, you are going to be aggregating the data. Aggregating means you need to give some kind of an output, right? So some kind of a patterns, some kind of an outputs, A team, BA team is going to be having. You need to aggregate the data. You need to give some summaries. So what is the total sales by brand wise? What is the total feedback, for the Apple iPhone, 10, 11, 12, 13, 14, 15, cameras rating, audio quality rating, video quality rating. You need to get the social media data and try to understand a lot of feedback. So all these things you have to aggregate the data, then give the aggregations. So cleansing is one work that you're going to be doing. So that is the second one is called aggregating. Aggregating means I want to know year-wise sales, city-wise sales, state-wise sales, country-wise sales, or brand-wise sales, or brand-wise year-wise, month-wise sales, or you can say country-wise, state-wise, year-wise, brand-wise sales. Like that, lot of aggregations that are going to be creating on the data and prepare lot of reports later. Clear? So all the process has to happen either with the Apache Spark. Apache Spark, why are we using? Because it is unlimited data, bigger amount of data. Otherwise, we are going to be storing the data into the different application like data warehousing, SQL, blah, blah, blah. Clear? So end of the day, what is the biggest problem for us? We are going to be storing the data and the cleaning will take a lot of time. So for the cleaning purpose, you cannot use ready-made transformations everywhere, right? So we may be using ADF, Azure Data Factory. So people, know about Azure Data Factory, they will understand. So what Azure Data Factory is going to be doing? Azure Data Factory is going to be getting the data from different places. Azure Data Factory, let me give you what Azure Data Factory is going to be doing. ADF and is going to be an ETL. ETL means what? It is going to be extracting the data, transforming the data, deleting the data. I have some data here. I have some data here. I have some data here. All the data ADF is going to be bringing it. It is a ETL tool. ADF is going to be getting the data. ADF is completely extracting the data from source number one. This is source. Source may be you're getting data from SQL or maybe getting the data from Java application, maybe getting the data from Excel application, or maybe some other application. All the data you are going to be dumping into the cloud. Cloud may be Azure, you may be using, or AWS may be using, or Google Cloud Platform. So, how in the cloud we are going to be creating a blob or a data lake? All the data we are going to be dumping it here. All the data will be here. So, as it is a dump, you take the data as it is, you're going to be keeping the data into the Azure, AWS, Google Cloud within that blob or the data lake. You have the data as it is. If you have 1,000 rows are available or 10,000 rows are available, so all the data is going to be having 10,000 rows here. But it is not a ready to use data. It is not a cleaned data. It is a very big amount of data. Now what we do, we are going to be using ADB here. ADB is Azure Data Bricks. It's going to be taking the data and it is going to be doing two things. One is called, it's going to be cleaning the data, and step number one, it is going to be aggregating the data. So it is going to be cleaning the data, aggregating the data, because simply it is going to be dumping. What is ADF? ADF is a transport services, lorry service. For example, I have tomato, potato available in Hyderabad. I have, tomato, potato, cabbage, lot of carrot, lot of vegetables are available. How do I centralize all the data? I need to use a lorry, a transport service. So all the transport or ADF will be lorry, getting all the vegetables from from different villages, different farmers. All the vegetables are going to be dumped as it is into the centralized warehouse. Clear? All the potato, tomato, cabbage, carrot, all the things are going to be dumped as it is. That is what is called transport. Your ADF is simply lifting the data, shifting the data, copy and paste the data. ETL means only that, nothing else. Simply exporting, importing data. ADF is going to be doing only that. So after that, what normally do? You got the data. After that, some people are going to be cleaning your data. Who's going to be cleaning? You have a labor, right? The labor work is going to be done by the ADB. ADB is your labor. Okay, it can have lot of labor people. So ADB, Azure Data Bricks, is going to be taking the data and putting all the data into the cluster. Now I'll be able to talk about a cluster, right? So ADB is going to be doing the first activity is called data cleansing. I got the data now, different villages, different fields. I have data coming from, let us say, Punjab. A lot of wheat I'm getting it from Punjab. From UP, I'm getting a lot of cotton. From some other place, I'm getting a lot of onion, lot of tomato, lot of potato. So lorry transport service will be only dumping the data into the different warehouse. You assume you have one warehouse called blob or data lake. All the vegetables are available. After that, you're going to be using a lot of labor service to clean the vegetables, right? After that, you're going to be neatly arranging them, and again you're going to be aggregating them. So how many potatoes you have, cleaned potato now, how many onions you have, how much of wheat you have, how much of rice you have. After cleaning it, now we are going to be counting. Counting means aggregation. That work is also labor has to do. Labor has to clean. Again, labor has to count how many cleaned rice bags you have. How much of wheat how much of wheat you have. So the labor work is going to be doing. One is called cleansing the data. The second one is called aggregating the data. And after that, you are going to be storing them. Everything cleaned data will be there. This data will be stored, used by AI or BA teams respectively. Clear? So what is ADF, Azure Data Factory? Means it is a lorry service, transport service. Get the data from the different places. Why different places? Because if you think about Amazon company is doing the business in India, in Africa, in US and UK, everywhere. So you think about Amazon company's data will not be there in a single place, will not be there in a single application, right? So Amazon company data, if you take it, they'll be having some data in SQL in Africa. They have some data in India in Java. They have some data in Europe in somewhere else. So we're talking about single company data, but all the data you need to bring it and you can need to keep it here. For that, we are going to be using ADF. ADF is completely or ETL software extracting, transformation, loading, and we are going to be dumping the data into some place. Clear? But this, large amount of data we are going to be getting. Then two activities we need to do. One is called cleaning the data. The second one is called aggregation data. So this activity will be done by the ADB. ADB is going to be using completely labor work. Labor work means cleaning. You need to get a tons and tons of potato, clean them properly, right? You need to, after that, you need to arrange them, clean them, arrange them. Aggregating means counting them, how much of potato we have, how much of green cabbage we have, red carrot we have, how many bad potato we have lost it, everything, whether it's good or bad. How much of potato we brought it from North India, how much of potato we brought it from Pakistan, how much of potato we got it from Europe. So everything you need to have some kind of a numbers. That numbers also this labor team is going to be working on. So, what is the purpose of ADB? ADB is going to be doing storing the data in the RAM of its computer, and it is going to be doing two labor activities. One is called cleaning the data. Second one is called after that counting and performing an aggregations and keeping it ready. So now how Azure Data Bricks is going to be dealing with that is what we're going to be understanding. Clear? So what is the ADF? I have clearly explained. Now what is ADB? I'm going to be explaining now, Data Bricks is nothing but your Apache Spark only. But why the name is called Data Bricks is given? As I told you, if you wanted to arrange, if you wanted to install Apache Spark, either you can go and install it. So you have Azure is going to be giving you lot of hardware and software for rental. AWS is going to be giving you a hardware software for rental. Google Cloud, you can get hardware software for rental, or you can have your on premises. On premises means own. You can buy hardware you can get Apache Spark and install. That is own or on premises. So instead of you buying, you arranging everything, what normally we do, we are going to be having a agent or a broker. So who's the broker now? Databricks. Databricks is the broker. So you wanted to go directly approaching them. So this guy is called a broker. So you tell them that I wanted to have, I would like to store some, let us say, 100 petabyte of data. That is what your requirement. And if you store the data, the next one you are going to be processing the data. That is what your requirement. So what you do, first of all, you need to take one go down for storage, right? For example, you have 100 tons of potato you have. You need to have a storage to store the data. You need to have one rental place. Instead of you go and search, you talk to one agent. So that agent will be taking a go down. Either you can go to Azure, or you can go to AWS, or you can go to GCP, or you can also use your own this one. Anything is fine. You can have your own computers and hardware and everything. So after that, if you wanted to clean the data, what software we need to have? Apache software. So one is that hardware you need to have. Second is that software we need to have. So instead of you going doing it, so you thought that you need 100 servers, and inside that I need to install software. So everything Databricks team is going to be arranging either in Azure or in AWS or in GCP. Clear? So you tell them that, hey, Databricks, I need 100 servers. Okay, I need some software because I'm going to be dealing with the big data. Big data means we have only so much software, Apache Spark. It is a free software. It is a free software, but software is free, but hardware somebody has to buy and keep it ready, right? So Azure company is going to be giving you rental hardware and rental software. So Databricks will be going either to Azure or to the AWS company or to the Google Cloud. What is a cloud? Cloud means I told you rental hardware, software, business platforms. These are clear. So Databricks will be the broker. He will be able to go set up 100 machines with the Apache Spark, and to work with that, you will be able to get a nice GUI. That's it. Okay. So end of the day, what you're going to be doing, you are going to be giving 100 petabyte of data. Databricks. Databricks is going to be broker or agent. He will be able to either put the data here or he will be able to put the data here. Then if you put the data here, it will become Azure Databricks. Clear? If you put the data here with the help of a Databricks, it will be AWS Databricks. If you keep the data in this platform, so then you will be called as a GCP Databricks. Databricks is a broker software or agent. Clear? So end of the day, what is the software it is going to be giving it to you? It is going to be giving you number of machines plus Apache Spark will be given, and easy UI and lot of configurations that you need not do manually at the Apache Spark level. All lot of configurations, lot of settings, lot of syntax, lot of compilers, lot of UI. All of them are benefit to you. It will be very easy when you use Databricks. Otherwise, configuring, and if you don't have the proper UI, user interface, it will be writing complex code. You need to have one uniform, because we are going to be writing code in Java, SQL, Python. Or if somebody is giving you different uh, compilers are different interfaces to work with, means you will feel very difficulty. So that is the reason Apache Spark we are not going to be using directly. We are going to be going to use Databricks. Databricks is a agent or a small application, you can say. This application is going to be giving you beautiful UI to work with the Apache Spark only internally. So that is what is called Databricks. Databricks is released in 2012, and Apache Spark is released in 2009. Clear? So if you're working with Azure, Azure is going to be giving you only the servers, and the Apache Spark is going to be installed there. On top of that, your Databricks software is going to be running so that you can write the coding in the data bricks. Data bricks is going to be offering you Scala, Notepad, a lot of things are going to be there. So everything you can store and you can write the code here itself. So that end of the day is going to be storing your data. How Apache Spark is going to be storing your data? Let us understand. Now, I told you Apache Spark. Apache Spark is going to be storing the data into the cluster. So, this is what you need to understand. Okay, what is a cluster? How it is going to be storing the data. Now, you remember, I have one washing machine. Let us say it is 7 kg or 6 kg washing machine. So, four people are there in my family. So, I have to wash my clothes. So daily what I'm trying to do, four people we are having. So I'm using a washing machine. I put the clothes so that my washing machine will take care of washing. Okay. Four people are working tomorrow. My father and brother, everybody will come. So tomorrow there is a festival in my family. So what will happen? We will run the washing machine not one time, two times. So two times we are going to be using the washing machine. Still, that washing machine is sufficient. Clear? So, so what we are doing, we are going to be having a combined family. We are now thinking that 4 kg, 6 kg washing machine is not sufficient. Everybody staying together. We have two more kids also today. Now, what we are doing, we are going to be upgrading the washing machine from 6 kg to 10 kg washing machine. Okay. So 10 kg washing machine is sufficient either one time or two times or maximum three times we may use so that we are going to be processing our clothes. That is what is happening. Now you assume you wanted to run a hostel. If you wanted to run a hostel, in hostel we have, let us say, 2000 people are there. Now tell me, for the 2000 people, can I get a very big washing machine? The answer is no. There is a capacity of washing machine, maybe 10 kg, 20 kg, or 50 kg bigger washing machines. So that means you cannot guarantee that if the people are increasing in your family or in the hostel, if you have 100 people in the hostel, you may use 10 kg washing machine 10 times. Okay, but if you have 2000 people, one washing machine is not sufficient. What you need to do? That is when we are going to be buying not only one machine, we are going to be buying lot of washing machines. Washing machine number one, washing machine number two. You may have different sizes of washing machines. We may have it. Clear? It may be 6 kg washing machine. It may be 12 kg washing machine. That is the maximum size. This may be 5 kg washing machine. This may be 7 kg washing machine. This may be 15 kg washing machine. I'm going to be buying. So, this washing machines are going to be working for me together. Cluster means making the machines next to each other. All of them are going to be working. You may be having 200 people cloths, you're going to be getting it. All the cloths, for example, you have 2000 items that you would like to wash. So, what we're going to be doing, one person is not going to be doing, we are going to be distributing the load. So, 2000 shirts you are going to be distributing across this, maybe 50, 10. So, this can take, let us say, 20 shirts. This may take more capacity, let us say, 100, 50 shirts. This may be taking only 10 shots. This may be taking, let us say, 30 or 40 shots. This may be taking, let us say, 180 shots. Like that, depends upon the capability you are going to be distributing. Clear? Like that, how many washing machines you have to buy, that you need to decide. That you need to decide whether should I use only one time, washing, or a couple of times also I can wash the clothes. So what normally we do, we are going to be taking the data. What is the complete load? Complete load may be 2000 shirts. You may be dividing 500 shirts first, then 500 shots a second time, 500 shots a third time, 500 shots, next time. I'm going to be dividing like that and get distributing the data. So instead of, washing the clothes in a bigger machine, what is that we're going to be doing? We are going to be using multiple machine. These multiple machines are placed, one next to the other. So this is what is called a cluster. Cluster ante ఒక దాని పక్కన ఇంకో దాన్ని పెట్టడం. Okay. Cluster means what? You need to arrange the items, one item next to that one more item. It is what is called a cluster. Clear? So here one machine is not going to be working. Multiple machines are going to be working. Now tell me, a small machine or a bigger machine, or tomorrow this machine is not working. Is there any problem for you? There is no problem for you. Now tell me, today you have 2000 shirts to wash. Tomorrow it may be 20,000 shirts. Tomorrow it may be 50,000 shirts or unlimited shirts. Is there any problem? Do you need to buy a bigger washing machine? No, no, no. Only you need to buy whether small machine, bigger machine, buy 100 machines more. That's it. Clear? So cluster is going to be having lot of individual machines. Cluster is going to be having lot of individual machines. How big data is going to be storing at the data? Big data is not going to be storing the data in a single machine. It's going to be creating a cluster. If you want to store large amount of data, it is not going to be storing in a single machine. It is going to be storing in a bigger machines. Maybe not need not be bigger machines, maybe any machine. Clear? Small machine, bigger machine, but not one machine. It may be 4,000, 5,000 machines are going to be putting it together. Clear? How many machines is one cluster can have? It can have a minimum one. Minimum one washing machine you can have, minimum 100, 200, 300, 400, 500 washing machines you can have. Like that, a cluster means it is not a single machine. It is a multiple machines working together. And it may be small machine, bigger machine, doesn't matter. Depends upon the size you are going to be giving the data. Now, what you need to do, somebody has to monitor, right? You need to have one machine is going to be monitoring all the data. You will have a master node. This is the master machine is going to be monitoring who's doing what. It is going to be controlling, right? It is going to be controlling who's doing what. One master node. All of them are called, I told you labor, right? All of them are called slaves. Okay. So in the cluster, you will have one master machine. This is also computer and remaining called labor. Labor means it is going to be one more smaller machine. So whenever you give the data, this data will be, you are going to be giving to the master. Master is going to be distributing. You give, let us say, 100 terabyte of data are going to be giving it to the master. When you give this much of a data, some data will come, depends upon the size. Some data will come, some data will come, some data will come, some data will come. Right? Depends upon the the machine capability, the data is going to be coming here. So here, what software is going to be having? Okay, to store data, I should have a RAM. So every computer will have a RAM, right? All the data will be stored in the RAM. And what software I am going to be using? Apache Spark AS. Apache Spark AS. Apache Spark AS. Right? In all the machines, Apache Spark, each and every machine you will have a RAM. The data will be going to the RAM. Depends upon the RAM size, the data will get stored in the RAM and it is going to be working and it is going to be processing the data. Cluster means not one machine. Cluster means multiple machines. These machines are thousands of machines, 5,000, 6,000, 10,000 machines. These machines are not very big machines. Maybe big machines, maybe small machine, it can deal with the data. Okay, that is the reason Chart GPT is very, very faster. Chart GPT data is going to be within the cluster. Cluster means not a single machine. Cluster means 1,000, 5,000, 10,000 machines. Depends upon the data. You keep on increasing. You have 2000 people in the hostel today, you buy 100 washing machines. Tomorrow you have 4000, 5000 people in your hostel, you buy 100 more washing machines. Even though 10 washing machines are not working, there is no problem for you. Clear? Even though one computer is not working for you, one slave is not working for you, will having minimum with one computer, that will be master, that will be slave if you have only one computer. If you have 1 plus 4, one will be master, 4 will be slaves. Clear? Master node, slave node. Add master node, child node. Clear? Like that, you are going to be having a cluster. Cluster can be very, very faster. Why cluster is very, very faster? All the machines are going to be working together. So if I have 400 machines, 400 shirts I would like to wash. So what I do? I'm going to be starting 4 machines parallelly. Because of that, cluster is going to be distributing. That's, data will be distributed and parallelism is going to be happening. Even though you have a petabyte, zettabyte of data, it will be faster. Okay, even though you have petabyte, zettabyte of data, it will be faster. One architecture is called a distributed. Not one guy is going to be doing parallelly. It is going to be distributing the data parallelly. All the machines are working together. 1000 petabyte of data also can be executed. What are the things you do? You may be cleaning the data. You may be aggregating the data. Right? If you have 10,000 rows, not one guy is aggregating the data. 10 rows, 10 rows, 10 rows are going to be dividing. You aggregate 10 rows. You find out the sum for 10 rows. I will take 10 rows. You will take some rows. So we are distributing 1,000 rows between 10 people. 10 people are taking only 10 numbers and aggregating. Aggregating means they wanted to sum up, right? So 10 people results, I'll be getting it. Again, I will get the final result. So that is how the cluster is going to be doing the work. So whether you wanted to clean the data, you distribute the data, you run. So you have to write the code, because if you give the data that is not sufficient, whatever be the code to clean that you're going to be running, that will be here, that will be here, that will be here, that will be here. So data and the code also will get distributed. For example, you write a logic. What is the logic you're writing? I wanted to remove duplicate data. One some code you're writing. The duplicate code automatically will be replicated everywhere. For example, you wanted to remove the strains. So 100 washing machines where the powder you need to have, right? Not only one washing machine. Everybody who wanted to apply, I wanted to remove the strain from the cloth. So go machine number one, you need to put that powder, strain removal powder. Machine number two also you need to put the strain removal powder. Like that, wherever there is a data, everywhere the code also will go. Clear? And both of them will work together so that code and data will be distributed and working together. You will be writing the code only once, but internally, Apache Spark is going to be doing all these things and you will get one output. Okay. End of the day, you are going to be distributing the data, processing the data parallelly, but output will be very, very faster because not one computer is working for you. Thousands of computers are working for you. This is what is called a cluster. Clear? This cluster will be automatically made available and by the data bricks. Clear? When you go to data bricks, it will ask you, you want me to switch on the cluster, because cluster you cannot run, right? So then and there it will take some time to switch on the cluster. If you have a bigger machines made, you need to switch on all 1,000 machines. You need to put off all 1,000 machines. So data bricks or the Apache Spark architecture is a very, very costly architecture because not one machine. It is going to be using minimum one machine or maybe thousands of machines are working together. Even though one machine is not working, the load will be given to one more machine. For example, this machine is not running. Now you will be able to take this load and give it to these machines. Increase the volume in these machines. Am I clear? So this is what you have to understand. Clear? So cluster is going to be one master node and many slave nodes. Okay? And it is a distributed architecture. All of them you need to tell in the interview. The distributed architecture, data and code will be distributed, okay, among all of them, and the machines are cheaper. So it is commodity hardware. Commodity means cheaper hardware. Commodity hardware. I can use any machine, 4 kg machine, 10 kg machine. Commodity hardware can be used. That means cheaper machines we can use. Not very, bigger machines we can use. Any use. Only thing is that if the data is increasing, increase your nodes. Okay, commodity hardware can be used, and because distributed parallel processing is going to be happening, parallel processing is happening here, and because of parallel processing it will be faster, and fault tolerance. If there is a problem, one system is not working properly, fault tolerance is, can be handled easily. Okay, error issues can be handled easily. Okay, so that is what. And it is going to be doing one more mechanism called uh, high availability. High availability is there. If there is a problem of one machine, there is no problem at all. Remaining machines will be working together. High availability, fault tolerance, all of them are availability. BILIT, right? High availability. So all of them are the advantage when you create a cluster. Okay, so that is what you need to understand. Every time it is going to be maintaining 3 copies of data. That is also you need to know. So normally, how your cluster is going to be storing the data. Okay, for example, I will take 4 machines. Okay, so this is 3 machines I have. This is what is my master machine. This is my master. This is my slave. This is my slave. This is my slave. Okay. So all of them are working it together. So I'm going to be, taking, for example, if somebody gives you, let us say, let us understand 75 uh, units of data or GBs of data somebody is given to process. Now, what is going to be happening? It is going to be distributing 25 GB will be here, 25 GB will be here, 25 GB will be here. Like that, it is going to be distributing the data. Now, this will be one copy of data. One copy of data it is going to be keeping it here. You can think like that. So, one copy will be keeping, one copy will be the original will copy will come. Okay, but you need to understand it is going to be making one copy will get replicated thrice. So this is one copy of data. For example, I have some data. I have 10, 5, 20, 7, 8, 7, like that. I have some data. What it does? It will take this. This is one partition. This is one more partition. And like that, you will have one more partition. Say 7, 20, 12, and 22. This is one more partition. One copy of data will go here. One copy of data will go here. One copy of data will go here. This is one copy. Okay. So it is going to be processing with this data. It is going to be processing with this data. It is going to be processing. This is only one copy. Second copy, what it does, second copy also it will take, it will keep in some place. For example, second copy, same data, second copy, it may be maintaining here. Okay. Again, third copy, it may be maintaining here. Okay, so that means you will have one copy here. What is the one copy? First copy, first copy 10, you have a 5, you have a 25. This is one copy of data is going to be maintaining. This is first copy. Second copy, same dot, again 10, again 5, again 25. It is going to be maintaining second copy here. And the third copy, same 10, same 5, same 25. It is going to be maintaining three copies of data. Remember that. Like that, it is also one copy. The primary copy will be maintaining, first, second, third. First, second, third. It is going to be maintaining three copies of data. Why? If this machine is a failure, you should not worry about data. For example, first copy data is you have stored it. This machine is now it is not working. Suddenly, the second copy it is available here. You can go to this machine, same work you can assign so that the second machine is going to be having second copy of the data. It can deal with the data. Clear? So if you give 75 GB of data, 75 GB of data will get tripled. It will be maintaining three copies of replications. Why? You have original copy and you maintain two Xerox copies. What is the problem? If you lose original copy or some data, second copy, third copy also available in some other machine. Clear? So the cluster is going to be maintaining three copies of the data. What is the meaning? If you give 1 TB of data, it will replicate it by thrice. So 3 TB of data it will become. It is not processing, but it will be keeping. Why it will be keeping? If some data is not, if machine is some machine is not working suddenly, I should not be worried. The master machine knows where is the second copy. The master machine immediately will be taking care of all of them automatically. Second copy is available here. I can go and ask my this slave node to do the activity because this machine is stopped working. This machine is stopped working. I have to use some other machines. How many replicas of data will be gone? Three replicas, cluster is going to be maintaining in Apache Spark as well as in Hadoop also. Hadoop is also going to be having same cluster architecture only. Cluster is going to be having a minimum one master and one slave, only one. So that will be master, that will be slave. I am the hero, I am the villain, like that. So minimum you have two machines, three machines, four machines, five machines. You may have 1,000, 2,000, 4,000, 5,000 machines. Commodity hardware means cheaper, risk-free, high availability, fault tolerance, right? Three copies of data it is going to be maintaining. If you lose one computer, second copy, it's going to be storing. Everything will be monitored by the master node. Clear? So when the work is done, this is going to be giving the results to the master node. Whether you may process the data, you may clean the data, you will be able to get the output here, right? You will give the data and you will give the program. I wanted to either clean the data or I wanted to do after cleaning. After cleaning, I would like to aggregate the data. The complete code, when you give, the code will be distributed to the different computers called slaves. It is going to be working. If one computer is not working, means second computer is going to be working and giving the final result to the master node. Master node is going to be giving you the final output to the end user. Clear? So internally, cluster architecture. Cluster means one machine is going to be kept to the next machine. All of them are completely parallel, and code and data is going to be distributed, and it is a distributed architecture. High fault tolerance, no risk at all. Commodity hardware, you can use cheaper hardware, you can use, need not buy very hi-fi computers, and you can store unlimited data. You might store 10,000 terabytes of data, 10,000 petabyte of data. Only keep on increasing the node size. 4,000 machines with 5,000, 6,000, 7,000, 8,000, 10,000 machines. It can accommodate unlimited data. Clear? It is not going to be storing the data in a single computer. Cluster is decentralized architecture. Remember that. Decentralized architecture. It is not going to be storing the data in a single machine, because single machine you cannot store unlimited data. It is going to be decentralized architecture, ADB, Azure Data Bricks is going to be creating a cluster, right? It is a parallel, very fast. All of them can work parallelly. 2000, clothes also can be washed within 1 hour. We are not going to be working, 100 shirts by 100 shirts. All the shirts can be distributed. All the washing machines can run parallelly. Clear? So this is what is called commodity cluster. These are the advantages of a big data. Either you use Hadoop or a Apache Spark or a Databricks. What is a Databricks? It is a agent or a broker software which is going to be storing data in a rental platform, either Azure or AWS or Google Cloud. And Apache Spark is going to be running in the each and every master node as well as in the slave nodes. That is what you got to understand. ADB is going to be working with your data. Clear? So ADF is going to be lorry transport, getting the data, putting the data in centralized location. After that, you're going to be running the cluster, taking all the machines, all the data, and going to be cleaning and going to be aggregating the data. Whatever that you wanted to give, you will be able to work with that. Okay. So big data may be structured data, unstructured data, relational data, even streaming data means live data. Continuously, you are going to be getting the data, weather forecasting data, cricket match data, streaming data, Sensex data, share market data. Your Apache Spark can handle. Your data warehouse SQL cannot handle live streaming data, right? Your data warehousing will not handle unstructured data, semi-structured data. Your SQL cannot handle unstructured, semi-structured streaming data. Clear? But big data can handle any kind of a data. Clear? So this is the guy for Databricks. He is the Godzi Ali, president of CEO. He was the founder of Databricks. Databricks is a broker software or agent software. It is going to be giving you easy UI to work with the big data. You can write any, you can write Java code, SQL code, Python code, only one UI. It's very easy to use it. Clear? Underline, it is going to be using Apache Spark in cloud platforms. Okay. So Apache Spark can have streaming data, MLib data, machine library data, graphics data, R, SQL, Python, Scala, Java, any language we can use. We can learn SQL and Python so that we can work with the Apache Spark, nothing but your data bricks. Okay. So you have any questions, you will be able to ask me. Data bricks for good for the streaming data. Batch data means OLAP or historical data, right? Timestamp data or graph data. All these things we'll discuss later. So don't worry about it. So data lake is one more good feature in the data bricks. I'll be talking about this later. So hope you understood what is a cluster and what is data lake and what is data bricks. Data lake, sorry, what is data? Azure Data Factory is a transport service, lorry service, and ADB is a labor, slave. Labor means what? It's going to be cleaning the data, aggregating the data. That's it. Not one labor, thousands of people working together, thousands of labor working together, thousands of slaves working together. Now, here, slave means a machine. Somebody has to control slaves, that is a master machine. Master node, slave node. Master node, child nodes. Clear? Even though one slave is not working, we should not be worried. Three copies of data will be maintained so that if one machine is not working, second copy will be available elsewhere. The master machine knows where it is available. So master machine is going to be executing that machine and giving the what do you say, a signal to start processing the data. This is what is called Azure Data Bricks and Azure Data Factory. Any questions? You're welcome. And hope you have liked this class, guys.